Why do some soldiers and firefighters seem to father more daughters than sons? Is it fate or science? Could stress, heat, or chemical exposure quietly be tilting the odds? Today, we uncover the gripping biological mystery behind how the environments we work and fight in may shape the very gender of our children. Section 1. The science of sperm and sex determination. Let's start with the basics. Every sperm cell carries either an X or a Y chromosome. If an X-bearing sperm fertilizes the egg, the child will be female. If a Y-bearing sperm wins the race, the result is a male. In theory, men produce X and Y sperm in roughly equal numbers. But what happens when that balance is disrupted? Can something in a man's body or in his environment change the odds? Modern science says yes, and the mechanisms are both fascinating and unsettling. Section 2. Heat, the silent sperm killer. The testes hang outside the body for one reason. They need to stay cooler than core body temperature. Just a few degrees too warm, and sperm production starts to falter. Now, imagine soldiers in hot gear, tank crews in sealed vehicles, or workers in steel mills. These environments can raise scrotal temperature significantly. Animal studies show that short bursts of scrotal heat, like 30 minutes at 42 degrees Celsius, cause waves of sperm damage. One key discovery: Y-bearing sperm may be more sensitive to heat than X-bearing sperm. In mice, this leads to litters with more females. In men, prolonged heat exposure impairs sperm motility and increases DNA fragmentation, possibly reducing the chances of male conception. Section 3. Stress, nature's reproductive filter. Now, let's talk about stress. Chronic psychological stress, like what soldiers face during deployment, affects hormone levels. Testosterone drops. Cortisol, the stress hormone, rises, and that hormonal shift impacts sperm production. Studies from war zones, disasters, and even terrorist attacks show a curious pattern. 9 months after extreme stress events, male birth rates often dip. After the 1995 Kobe earthquake in Japan, male births declined significantly. In Slovenia, after a short war in 1991, the sex ratio dropped sharply. Sperm samples showed lower motility after the conflict. Why would this happen? One hypothesis is that male embryos are more fragile, under stress, whether at S, in the father S testes, or the mother S, will male fetuses are more likely to be lost. In short, stress may not only reduce male sperm performance, but also male embryo survival. The result: more daughters. Section 4. Toxins, chemical roulette for offspring, sex. The most startling effects, however, come from toxins, especially endocrine-disrupting chemicals like dioxins, PCBs, heavy metals, and certain pesticides. Take dioxins, dangerous industrial by. In 1976, an accident in Seveso, Italy, released high levels into the air. Men exposed as teenagers later fathered far more daughters than sons, some as low as 38% male births. The effect persisted years after exposure. Lead is another culprit. Men with high blood lead levels father fewer sons. One study showed a sex ratio of just 0.86 in high lead workers. Pesticides also skew birth outcomes. A large Japanese study found that fathers who regularly handled insecticides had significantly more daughters. Only about 44.5% of their children were male. These chemicals may damage Y sperm more than X sperm, or disrupt hormones in a way that makes male embryos less likely to survive. Section 5. Experimental and population evidence. Scientists have even suggested using shifts in the sex ratio as a kind of early warning system and indicator that an environment might be harming male fertility. Some key findings: in animal studies, heat or toxins consistently lower male sperm viability and lead to female-skewed litters. Human studies across disasters, wars, and polluted regions show declines in male births after acute or chronic exposures. Even routine occupations like farming or firefighting show sex ratio effects if they involve pesticides or high stress. For example, in the US, a massive analysis of 150 million births found that areas with more lead pollution had more girls. Regions with high PCB pollution had slightly more boys. The effects aren't always huge, but they are consistent. Section 6. What about soldiers? So what about Marines or other military personnel? Multiple studies have asked whether their children's sex ratios differ. Submariners, for instance, are exposed to heat, poor ventilation, and high CO levels. Yet, data from over 7,000 births in U.S. Navy submariners show no significant sex ratio change. But ground troops in combat zones tell a different story. High-stress deployments, exposure to burn pits, or contact with chemicals like Agent Orange could have complex reproductive effects. Some Vietnam veterans exposed to dioxin and Agent Orange fathered more daughters, but results were mixed, possibly due to inconsistent exposure levels. Fighter pilots, no clear shift. High G-forces don't seem to change sex, so the answer is nuanced. Not all military exposures affect offspring sex, but those involving chronic stress or reproductive toxins likely do. Section 7. Global patterns and public health signals globally. Subtle shifts in sex ratios are being tracked by when a region suddenly sees fewer boys being born, scientists ask, what's happening? Environmental health researchers are beginning to treat sex ratio changes as signals of reproductive harm, like canaries in a coal mine, whether it's smog, industrial waste, agricultural runoff, or a psychological trauma. These changes suggest that modern life may be altering the biology of conception. Section 8. Biological mechanisms behind the shift. Let's tie it all together. Why are Y-sperm more vulnerable? Y-bearing sperm are typically faster but more fragile. They have less DNA-protecting proteins than under heat, oxidative stress, or toxin exposure. Y-sperm may die off faster or carry DNA damage that prevents conception or causes early miscarriage. Similarly, male embryos require slightly more energy to develop and are more likely to be lost during early pregnancy when the mother's body is under stress. In evolutionary terms, this may be nature's way of protecting future generations. When resources are scarce or danger is high, females may be favored because they have higher reproductive certainty. Section 9. What can be done? So, what does this mean for us? If you're working in a high-stress, high-heat, or high-toxin environment, your reproductive health may be at risk, especially if you're planning to have children. Protective strategies include wearing breathable gear in hot environments, taking regular breaks to cool down, using toxin-free materials wherever possible, avoiding unnecessary chemical exposure, prioritizing mental health and stress reduction. Couples struggling with infertility or repeated miscarriage may also consider testing for environmental exposures or sperm DNA fragmentation. Closing thoughts, the sex of your child may feel like a coin toss, but the coin isn't always fair. Stress, heat, and pollution don't just affect our health, they reach across generations, influencing who gets conceived and who doesn't. As science uncovers more, one thing becomes clear. The world we build shapes the children we bring into it. Summary of key takeaways. Heat can impair sperm quality and may reduce the odds of fathering boys. Stress disrupts hormones and increases male fetal loss, shifting births toward girls. Toxins like dioxins, lead, and pesticides damage Y-bearing sperm or disrupt hormones. Environmental exposures are linked to subtle but real shifts in the sex ratio at birth. Military or occupational groups exposed to these stressors may father more daughters not due to myth but biology.